So thank you everybody for being here. Thank you for those that are at home. I hope you can hear me well. My name is Jerry. I work for the University of California Cooperative Extension. It's kind of a mouthful, but it's very important that you guys know who we are and what we do, so that the county say, these guys are doing a great job, and then they give us more support. Right, Gary? Right. So we are the University of California Cooperative Extension. We're not UC Davis. We're not UC San Diego. We're the Cooperative Extension. That's what UCC there stands for. And today is Thursday, but today is what we call the last Wednesday meeting. And I promise that from now to Judgment Day, every Wednesday at 1 p.m. in this very room, we'll have a meeting.
Every last one.
Every last Wednesday. I'm sorry, every last Wednesday. I got excited for a second. Thank you for keeping me on my toes, Enrico. And I promise that other times there will be some more entertaining topics than today. But today we're going to talk about field tools that you can use to measure nitrogen and nitrate in the field. And so I'm going to give it a 30 minutes introduction about units and about concentrations and about lexical conductivity and about boring stuff. And then the other 30 minutes will play around with water and various concentrations. This is the first and last housekeeping item. If you scan that QR code, it takes you directly to this website. And this website is my website. If you go there, you see my ugly face there and a lot of videos and a lot of things that I put there. But you also have a link there to sign up for email updates. So now you cannot see very well because we have that Zoom thing there. But it will keep you here where you can sign up for email updates. And if you're here, presumably you got it already. But there's 3 categories here that you may want to sign up for. One is nursery and floriculture, which is what I do. IPM is what Eric does, and of course there is a little bit of overlap between the two. And also here there's a newsletter. I've heard some of you wanted to receive the newsletter, and that's how you receive it if you sign up there. And if you're confused, you can talk to me. So I want to talk about nitrogen. Who wants to help me? What kind of forms of nitrogen do we have out there? You talk, I'm going to take a break now. Tell me about nitrogen. What kind of forms of nitrogen do we have out there?
Organic and inorganic.
Very good. Do you want to talk a little bit about the organic ones? Which one are the organic?
Like humus, decaying,
Okay.
animals, plants, anything that's kind of breaking down.
Sure, breaking down, but what are in biology, in biochemistry, what are the molecules that contain nitrogen? You also make a smoothie. These people that want to have big muscles, they drink smoothies with that stuff inside. Or maybe some bars, and the bar says, this stuff is full of nitrogen. It's say no carbs, it's full of proteins. So one form of nitrogen is the proteinaceous one. Oh Lord, what did I do? Is the proteinaceous one, right? Proteins are molecules that make up our bodies, and also a lot of those components that we're talking about, including that organic fertilizer that I put there. Then there is another form of nitrogen that we're quite familiar with, and now they're recording me, so I cannot say inappropriate things, but you have to do with it on a daily basis. Let's put it that way. Who wants to tell me? Close. It's urea. And every day we have to do with it, multiple times a day, right? Because that's how our body gets rid of the nitrogen that is evaporated. When it breaks down protein, it ends up with some ammonia part of nitrogen. And so it makes these groups NH2, and it puts it together in this molecule, so now it doesn't hurt you anymore. And this is also used for fertilizer, right? How many of you have used urea as fertilizer before? Some of you have, right? So if you use urea, make sure that you know that you cannot use electrical conductivity as a trick to measure how much urea is in there. And I'll get to it in a minute. But remember this thing, urea does not show up in terms of electrical conductivity. Then another one is amino acids, and amino acids are the blocks, the building blocks that make up proteins. You connect one amino acid after the other, you make this big long chain, and that's what we call a protein. How about inorganic nitrogen? Who wants to tell me about mineral nitrogen? That stuff that is in fertilizers. Help. Who wants to tell me? When you apply fertilizer, say what?
You mean like calcium nitrate?
Nitrate. Nitrate is one of them, right? Nitrate is what we call mineral nitrogen. Hey Al, how are you doing? Good. Nitrate is one of the forms. It's one of those forms that we apply with fertilizer. What's the other one? Ammonium sulfate. Ammonium. It doesn't matter if it goes with sulfate. It doesn't matter if you go with chloride. It can go with any negatively charged ion. But the important part is the ammonium. So we got nitrate, and we got ammonium, and we got nitrite. Now I'm going to talk later about the fact that nitrate doesn't count too much. We don't encounter it very often. But the two most important ones are nitrate and ammonium. And I want you to remember that nitrate is NO3 and ammonium is NH4 plus. Then here, for the sake of comprehensiveness, I guess I also put N2, which is a gas, and we breathe like 80% of the air that we breathe is nitrogen, but it's molecular nitrogen. So it's very unreactive, it's very inert. Any questions about this? Who's bored? Yes, question. You are? No, me too. What's up?
The nitrogen in the gas state.
Yeah.
In the air.
Yeah.
When it rains, it can be incorporated into the rainwater.
No. So you have when it rains, you get something that is called acid rains, but those you can get something that is called deposition, that is nitrate, but those come from, I think, industrial activities or sometimes lightning. Lightning can break this N2, but this N2 is very, very inert. It does not want to react with anything. That's why it's everywhere, but doesn't react. And you have to add a ton of energy to break those bonds to make it react. And that's what the fertilizer industry does that. And it takes so much energy that the prices of fertilizer are connected to the price of oil and to the price of, like, with the war in Ukraine, now the fertilizers are more expensive because there is less natural gas, and they use a lot of natural gas to make fertilizer because so much energy goes into that process. So N2 is very inert, but yes, there is some nitrogen that comes with rains, but it comes from other sources. So this is part of the answer to your question. We have a nitrogen cycle. Most of you saw this when you were in middle school, and then you have forgotten it. But so you have this big cycle, but the things that are more important for us are ammonium, nitrate, and nitrate. And some come naturally from decomposers, like Madeline said, but also many of what we're interested in comes in fertilizer from urea or from ammonium and nitrate. And that super energy intensive process that I was talking about is called Haber-Bosch. Some Germans invented it, of course. But the important thing here that I want you to know is that ammonium becomes nitrite. Hey, Greg. Hi. And nitrite becomes nitrate. And this is something that in California condition happens within weeks, because it's warm here in California and because we apply and because we irrigate. So when I was back in Italy, I used to do rain-fed agriculture. That means that for 3 months a year, everything is super dry and super hot, and microbial activity doesn't move very much. But here in California, whatever you grow, probably you will be irrigating. And so the soil or the substrate or whatever, wherever you grow your plants, it will be relatively warm and it will be relatively wet. And that's where this bacterial activity is very fast. So long story long, whatever you apply, if you apply urea, it will be broken down into ammonium by an enzyme called urease, and then ammonium will be broken down, will be converted into nitrites, and then nitrite will be converted into nitrate. So again, long story long, whatever you apply within weeks, it will become nitrate. And why is nitrate a problem? Why is nitrate a problem? I don't know if it's a problem. Why it's challenging?
This is attached to the child.
It's very soluble. It's very soluble. It's super soluble in water, and so it follows the water cycle, and so it ends up in some lagoon, or it ends up in some pond, or it ends up in the creek, and the water quality regulators have very little sense of humor about this kind of stuff. Any questions? And that's why we're all here, right? That's why we're all here learning about these things. Now I want to talk about concentration. When you measure a concentration of something that is dissolved in water, we call it a solute. And the water, we call it a solvent. And the units are ppm. What is ppm? Parts per million. Parts per million. It means that you have this many parts, this many units, this many molecules of that stuff, of the solute, per million molecules of water. The other way to think about it is milligram liter, and that's the easiest for me to think. I think about, okay, I have a big mug that is 1 liter. I have 1 liter of volume of water, and I put 1 milligram of nitrate in it. So that's when I have 1 milligram liter of concentration. Does it make sense? I take it as a yes.
Yeah.
You can also use a trick that is called electrical conductivity. What is electrical conductivity? Greg, what is electrical conductivity?
How, say, a liquid conducts electricity.
It's the ability of a liquid or of a solid or of an object or of a material to conduct electricity. So, yes, sir. Yes, sir.
You may have covered this already, sorry.
Yes, sir.
I was late.
No problem.
Can we have the slide?
Sure.
The slides?
Sure.
Oh, okay, good. Then I
You
don't
can
have to
even-
write so
Yeah,
fast.
sure. I sent you the slide.
It's gonna cost you though.
So, you bring the cookies next time.
Okay.
So for example, there's different materials and different conductivities. For example, copper has really good conductivity. That's why we make wires out of it. And then maybe rubber or plastic doesn't have very good conductivity. That's why we line those wires with that rubber so they don't touch each other. And so somebody decided that we use some units to measure electrical conductivity, and some units, so these units are called Siemens. And there was some German guy that in the 1800s worked with electricity, and so somebody decided that today, in this different place and time, we still use his name for these units. So the units for electrical conductivity, whether you know it or not, and most people don't know it, they tell me, I got 2.3 EC, Jerry. I got to 1.8 EC, right? What they're trying to say is I have an EC, I have electrical conductivity of 1.8. This is Siemens per meter, ES/M, which is the same as millisiemens per centimeter. You see up here in the HANA, it says MS. Where's the HANA? I have it sitting around somewhere. It's there. It says MS, it stands for millisiemens, and they forgot to say per centimeter. I don't know why, but that's what they're trying to say. So pass it around and play with it, and you see that it will say MS up there. So that's a Siemens per meter or millisiemens per centimeter, or millimass per centimeter is the same. So these are older units, but you still find them somewhere. I want you to know that it's all the same. I just want you to know, don't be scared if you see this stuff, but it's all the same. Now, we use this trick that we measure the conductivity of water, but it's a trick. I want you to make sure that you remember this is a trick. We measure the ability of this water to conduct electricity, because that's related to how many ions, how many total dissolved solids are in that water. But it's not a 100% univocal relationship. The conversion is about 640 if you have a lot of chloride and nitrate, which probably you do. But it can be as low as 500 or it can be as high as 700. And I want you to pass this around also. They call it the truncheon. It's another EC meter, but it has one scale for EC and one scale for total dissolved solid converted at 500, and another one converted at 700. So they tell you, look, your EC is 1, because I measured it, so I know it. I measure EC. I'm an instrument that measures electrical conductivity. So I know for sure that your EC is 1, but it could correspond to about 500 ppm of total dissolved solids, or to 700 ppm of total dissolved solids, or somewhere in between. So I want you to be aware of this, that this is a conversion that's a little shaky.
It's on this, it says C, what's that stand for?
You know, I had to look it up for this talk. Believe it or not, conversion factor is the same as EC divided by 10. I don't know who came up with it. I had never encountered before. I was scared that somebody asked that question.
The decimal point over is what they did.
Okay, so thank you for asking. You make my day. Thank you for asking that question. Sometimes you will find microsiemens. Yes, sir. Yes, ma'am.
So those two models, that one kind of gives you more range and that one's more exact. Is that the
No, the HANA gives you millisiemens,
okay.
which is what the instrument measures. The instrument measures directly electrical conductivity. And then I think you can go inside and decide what the conversion factor on that one too. You can go in the settings and punch in, like, I want you to convert at 600 or I want you to convert at 640. But I'm told that for irrigation water, the one that they recommend to use is 640. 640. Most people talk about electrical conductivity. They don't even go into ppm of total dissolved solids. So, but I want you to be aware. Sometimes I talk to people and tell me, we have this well. It's very salty. We got 3,000 parts per million. So inside my head, I have to say, okay, 3,000 divided 600. How much is that? So because I think in EC. Does it make sense?
You mentioned a range though. You went from 500 to 700 for one
millisiemens per meter. Yeah.
So it's a range then.
Yes, yeah.
This is just the average. So
yeah, it's an average. The truth is, and I'm not strong enough in chemistry to answer this question, but the truth is, different ions have more or less capacity to conduct electricity. And so, depending who they are. For example, I know that up in Ventura, they have wells with ECs really high, like between 1.5 and 2, but it's not too much of a problem because most of it is sulfate. And sulfate doesn't hurt plants as much.
right.
And so when I was there, I was hanging out with Ben Faber, and it's like, okay, we have a well here. It's got 1.8 decisiemens per meter of EC, and I was like, what? And it's like, yeah, it seems high, but for us it's not too high because the ions are different. So I'm guessing that in that case the conversion was 500, so it's lower than you think.
How did he find out that it was sulfur and not another nitrate?
So they know that, but somebody must have taken a sample and sent it to the lab, but I know, I'm told that in Ventura, they have really high C, but it's not.
It's a bit of a moving target then, really, isn't it? I mean, depending on what the dissolved solid is.
It's an estimate.
Yeah.
It's an estimate.
Yeah, it's not
Yeah.
exact.
But it's a good trick. It's a good trick because these instruments are very cheap and they're very simple. And it's a very simple.
Which in the ballpark. You know, kind of know where you're at.
Exactly. So nitrate and nitrate, now I'm behind a little bit. We don't find relevant concentration of nitrate because everything gets converted to nitrate. So later, when I have you playing with the colorimetric strip, you see you have the scale for nitrite and one for nitrate. Use the one for nitrate. You have the tip of the strip measures nitrate, and the lower part measure nitrite. Use the upper one, and I bet you $1 that the lower one will not even change color because in that water there will not be any nitrites. So yesterday I was preparing this talk and I said, okay, let me Google. I want to talk about what's the limit for drinking water. We have a limit of nitrate for drinking water. Who wants to tell me why?
Blue baby syndrome.
The blue baby syndrome. What's the blue baby syndrome?
Lack of oxygen to the child is tied up.
Exactly. There is some stuff called hemoglobin in our blood, and nitrate is kind of similar to oxygen. So this hemoglobin gets confused and binds to the nitrate instead of binding to oxygen, and now the baby becomes blue. That's not a good thing. So the EPA said, okay. Nationally, there cannot be any drinking water that is above 10 milligram liter. Check this out. I went to the EPA and it says the standard is 10 milligram liter of ppm for nitrate. Then you go to the water boards and they say 10 milligram liter for nitrate as nitrogen. What does that mean? Nitrate, so here they say nitrate, and here they say nitrate as nitrogen. What do they mean, as nitrogen? And then I found this other one from the extension of the University of Georgia, all reputable sources, right? Here they say 10 ppm or milligram liter nitrate dash nitrogen, or if expressed as nitrate 45 ppm. What the hell? What do they mean? If expressed as what? Nitrate as nitrogen. So this stuff has been historically confusing to me, which brings me to the infamous chicken theory for Jerry's chicken theory for units of nitrate concentration. So you will find out there in your journey, in your nitrate journey, you will find out there two kinds of units, and I wrote them all here. So you have them separated by these blocks. You'll find nitrate, you find NO3 minus, and you will find something like that says is expressed as nitrate, as opposed to nitrate N, nitrate nitrogen, NO3N, and nitrate expressed as nitrogen. And these are different units. And your job is keeping them straight in your head and being able to convert from one to the other. They're different things. They're very different things. It's like I tell you a recipe. I call my mom and I say, hey, what's the recipe for the chicken? And she gives me in grams, and then you use pounds instead. The same thing. You need to convert one to the other. And the problem has to do with the fact that nitrate is this big molecule with the nitrogen in the middle, and these three big heavy oxygens around it. What's the atomic weight of nitrogen? Who's fresh of college?
Repeat the question again?
What's
I'm sorry.
I think it's 14, 16, 14. What is it for oxygen? 16. So they're really close. So those three oxygen weigh as much weigh as much of that nitrogen in the middle. So the other day, my girlfriend asked me to cook this chicken for her. And so I called my mom and she said, well, you need a pound of chicken. And then I removed the legs, the feathers, the head, and I was left with only 0.22 pounds of meat after I removed all that other stuff. You know, and then I cooked this thing and the recipe was a disaster, and that's why I do not have a girlfriend anymore.
Right.
There are a couple of other reasons.
So did you butcher your own chicken?
Kind of skinny chicken to start with. So for every pound of chicken, when you remove the stuff that you don't need, when you just pull out the essential part, the inner essential part of it, you will be left with only about a fifth, only 0.22 pounds of chicken meat, or you can say chicken M, or I guess you can say chicken expressed as meat. And this is, I mean this as a stupid joke, but this is a stupid joke that I keep in my head to keep things straight. And I think, okay, when I see, since N is kind of similar to N, I say, okay, they're talking about as nitrogen, they're talking about the essential part of it, not the whole thing, only the essential part of it. And so, all things being equal, these units will be smaller than this. But you will find yourself saying, okay, 45 milligrams, do I have to divide by 4 or do I have to multiply by 4? Which one should be larger? Which one should be larger? So these ones should be larger, the nitrate should be larger, and the nitrate N should be smaller. And if you are confused, in a minute I'll have you play with those things so you will get even more confused. And if you think that stupid jokes can only get to a certain point, then you can think of that oxygens as the feathers and the legs and the head of the chicken. But again, these are the units. So one is about 4.5 times larger than the other one. And I'll have you play with those in a minute. Notice that you can buy instruments and now we'll play with those instruments. And some will tell you nitrate, will tell you, check this out, mgl, milligram liter as NO3. So these are nitrate, this is the whole chicken. This also says NO3, ppm NO3. And check this out, this says, well, I promise that it says nitrate back there. And those other ones says nitrate nitrogen. You see the wheel, that wheel there says nitrate nitrogen. Here it says nitrate nitrogen. Check this one out. Here it says NO3N, and here it says NO3. You see this number? So these colorimetric strips, I guess they're nice enough to give you the answer in both units. But check this out. What's the conversion? NO3N is 2.3 and the other one is 10. How many times apart are they? Well, 4. So Jerry didn't lie.
Your chicken thing worked.
The what?
Your chicken thing worked.
Right. Exactly, the chicken thing worked. So every time it's about 4 times to go from one to the other. What's going on now? Okay, now I want to talk about another German dude. Now I want to talk about total nitrogen, and I promise we're towards the end. Total nitrogen means the organic stuff, all those proteins and humus and all those things, the proteins and the amino acids and the urea, plus ammonium, plus nitrate, plus nitrites, and this is what we call the mineral part. The organic part plus the mineral part is everything. It's the total nitrogen. Notice that here I say nitrate N, right? It's only the weight of that smaller part. It's only the weight of that essential part. It's like I have a recipe with chicken and beef and pork, and I need to sum the weight of the meat. I cannot sum the weight of the bones of pork and stuff. So make sure that when you sum these things, you need to convert with the right units. Who's confused? Except myself, only myself? You will find sometimes these TKN. What's TKN? Who has seen TKN before? All right. So there was this guy, Kjeldal, some Danish guy that worked, believe it or not, he worked for a beer company. Turns out that you need to know how much protein is in the malt, like in the barley, to decide how you make the process, how to make beer. Where's Mike when we need him? Where's Mike Milano? Yeah, I know he makes his own beer.
Yeah.
So this guy worked for this beer company, and they told him, okay, you need to find a method to measure how much protein, how much nitrogen is in these malts. And he came up with this idea that you need to digest all these proteins. And so it's kind of analytical chemistry, but they in the lab, they boil all this stuff until all the protein and until all the organic part becomes ammonium. And then they titrate the ammonium. But what if there was some ammonium already in that solution? So basically this TKN means organic plus ammonium. We don't know which one is which. But maybe there was some ammonium and then there was some proteins and we digested everything and the protein also became ammonium. And now we measure all the ammonium. And so it's these two. So sometimes you will find that total nitrogen is TKN plus nitrogen plus nitrite. I'm boring you to death. I'm boring you to death about these things because if you understand this, then you can compare different things. For example, the basing plan for Rainbow Creek says that we cannot have more than 1 milligram liter of total nitrogen. And I'm sure that some of you know that very well. And last summer I was in Italy, and you know these Italians like to drink this fancy bottled water, some Pellegrino and stuff. I think they think it's hip to spend $10 on a half gallon of water. But also I have a ton of regulations in Europe. So if you think that California has a lot of regulations, try Europe. And so if you sell water, you have to disclose the chemical analysis. And so I was there hanging out with my mom, and she was drinking this water. And check this out. Nitrate 9. So if you convert that to nitrate N, what do you get? 2 or 45? 2. You have to multiply by 4, you have to divide by 4. You want a larger number or you want a smaller number? So divide or multiply? Divide. So what's the answer?
Roughly 2.
2! About 2. So check this out. Italian fancy people drink more, they have more nitrate in their water, have more total nitrogen in their water than the one that we allow in the creek. So you can go out there and drink the creek.
Thank you for that.
So we can start balling that and selling it then for $10.
We'll ship it to Italy. Okay, liquid feed. Some of you have nurseries and use liquid feed, and you can go on a book and say, okay, I'm growing petunia. How much nitrogen per liter milligrams of nitrogen per liter I need for my petunias? And you can look it up here: 200, 120, 89, right? Or you can look up the Tables Red book that says 50 to 100 ppm, 100 to 50 ppm, 150 to 200 ppm, right? So somewhere you will find the information that some guy smarter than me came up with that tells you, look, you're growing chrysanthemum, 150 ppm of nitrogen. Then you go to your irrigator and you tell him, I want 150 ppm of nitrogen. What does he answer?
Is it constant liquid feed or periodic?
That's a great question. But that's not what the irrigator will answer. The irrigator will answer, what do you mean? Because the way the irrigator thinks is pounds per gallon in a stock solution, right? They have this big bucket and they put from the bag, they pour 1 pound into They have 3 liters, three gallons of solute solution. They put 3 pounds, and now they have 1 pound per gallon. And then they set the dosatron at 1 to 100, and who knows what's the final concentration of nitrogen in ppm? How to convert it? Who knows? All right.
I do. Read the chart on the fertilizer.
There you go.
So I made an Excel spreadsheet here, and you can scan this code, and it keeps you to the page where you can download it. And so you get your fertilizer 17,517, or 20,10,20, or 16,4,8. I make sure I put one picture of everybody so Donette doesn't get mad at me and Karen and everybody. So you put the numbers here, you punch in these numbers here from your fertilizer, and then you say, okay, 1 pound per gallon, and I've got the dosatron at 100, and out here it spits out how many ppm of total nitrogen, and it also gives you the phosphorus and the potassium. So use this tool, and if you're confused, talk to me. And there's also a YouTube video where I interview Don Marhat and he tells you things about nitrogen concentrations. If you grow in the soil, whether you grow vegetables or you grow citrus or avocados, you may be interested in asking yourself the question, is there nitrate there where my roots are? I know nothing about avocados, but I know that their root system is pretty superficial. Right, guys?
Yeah.
Pretty superficial. How many inches? 12 inches. So maybe you can go out there with one things like this, and you walk around with a bucket. You walk around your grove with a bucket, and you push this in the soil. You get one sample, and you put it in the bucket. You keep walking around, and now you have this bucket full of these samples, and then you mix everything together, and you can use this procedure that it was originally made for vegetables to ask yourself the question, how much concentration of nitrate do I have where? Am I over-irrigating? Am I pushing all my fertilizer deeper than my root can reach it? Is it there where I want it to be? Is there enough? Is it not enough? So if you scan that code, or if you talk to me later, I can send you this procedure, and basically you take the soil, you put it in a solution of calcium chloride, you shake it, and then you measure the nitrate concentration with those strips. To grow in containers with controlled release fertilizer, there is or even with normal granular fertilizer, there is a procedure called pour through. And you can scan this code, and basically there is table depending on how big on the size of your containers, you irrigate and you collect some leachate at the bottom of the container, and then they give you tables and they tell you, look, your total nitrogen should be 100 to 150 ppm. So that's why if you have containers, that's how you collect some leachate and you measure nitrates. So now that everybody is asleep, I'm gonna wake you up, dividing you in 4 groups. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Wanna be 3? I'll be 4. Okay. Okay, so group number one is gonna measure EC, which is the quickest, I call it even more than quick and dirty. So you can look up, I put there calcium nitrate, you guys can go all to that table. I put there calcium nitrate, and I put there some 17,517. This is the simplest way that you can do. You can look up, this is from Red Book, this is from the label on the fertilizer. They tell you, look, if your EC increases by 1 decisiemens per meter, or check this out. They say they use millimos, those old units that I was talking about earlier. Here they tell you, look, if your concentration goes up by 1, it means that your parts per million of nitrogen is 150. If your EC goes up by 137, then you're at 200 ppm of nitrogen. So you look it up from the table. I put there the 17517, and I put there some calcium nitrate. So what you're gonna do, you're gonna go there, there's some water there. First you measure the EC, you write it down. Then you add some fertilizer, you shake it, you measure the EC again. And you look up on these tables how much concentration of nitrogen you have. Does it make sense? You know what you're doing? Okay, once, go do it. Go do it. Now, twos is a method that is not the quickest and dirtiest, but it's still quick and dirty. You can use the colorimetric strips, and you can go on that table or drag it. And there are a lot of different strips, and these are used for aquariums and pools and stuff. You just pull out one of these strips and you put it in the water, and then you compare it, the color with the colorimetric scale. But be careful. Some of these give you units of nitrate, and some of these give you a unit of nitrogen. So I want you to measure the same water with 2 of those that give you different concentration, and then you compare them and you tell yourself, wow, Jerry was wrong, Jerry was right. I have to multiply by 4, I have to divide by 4. Which one is which? Okay, any questions? Notice that when you use the 17517 with this method, you will not be able to capture the ammonium, because this thing only measures nitrate. These instruments only measure nitrate. And the other one is this, it's called the Horiba. It's called the electrode-based meter. And it does the same, it just puts some water there and it gives you a number. So who are the twos? Whoever are the twos, come to this table, and you have some water there, and you have some calcium nitrate, you add some water, you can measure the water, you can measure the nitrate in the water by itself, then you can add the calcium nitrate, and you convince yourself that the thing changes color. Does it make sense? And then later, now that you have learned how to use these tools, later you can use it for your orchard or for your nursery or whatever you grow. Trees, where are my trees?
I'm a 3.
All right, my trees.
Yeah.
Where are my trees?
1.
My trees are here.
3.
My trees are here.
The mix.
Yeah.
So my trees are gonna use the method that is a little bit more
Maybe if it was 3 and 4.
refined. Here I made a solution for you. I made a solution at 150 ppm. So you're gonna use this machine that's called the photometer. And you need to get this cuvette. You put the sample in this cuvette. You put it in the machine.
The sample water.
It has it 0.
I think so.
Buckets, and you have to read it 0. Then you add the
I
reagent.
think it's maybe to blend it.
Shake it a little bit.
Otherwise, it's right here.
Put it there again. You push read. And the instrument is gonna say, okay, you have to wait 4 minutes. 4 minutes, it's gonna start the timer of
Nitrate and nitrate.
4 minutes while the reagent reacts.
It's not even registering.
No, that you change, that's all.
Now you can handle.
Clean it. Where are my 4?
Reading there?
My 4.
Zero.
Yeah.
So it has no reading at all.
Okay, where are my 4s? All right, you guys are gonna measure ammonium. What's the 4?
Maybe
You guys are gonna measure. Everything is gonna measure everything at the end. Everything is gonna measure everything at the end. You guys are gonna do that with ammonium. So I made a solution for you.
Oh, so you're gonna say it was 0?
This is the solution you're gonna use. So this is the cuvette you're gonna use. And this actually, this instrument walks you through and tell you what to do. So, this you get this cuvette, you get this syringe. You get 1 milliliter, that means this whole syringe of sample. Put 1 milliliter inside the cuvette. Then you add, where's my reagent?
What's in that? So
Yeah,
that's pretty 0 too. They're both. So that one is really
This reagent.
deep purple.
Oh, you're right. Oh, you're right. Okay.
This big reagent.
So 10.
You put 9 milliliters until 10. You see
So
there's this line
what's the
at 10.
top line represent? Nitrate?
Night.
This line at 10.
At night.
So you put 1 milliliter of that one.
Yeah.
So that would be what you expect. There's no
Shake
nitrate
it a little bit.
in the fertilizer. It's
You
all
put it there. And it's
You're
0.
getting a reading.
So it looks at it, now you have to wipe it. Because you
Oh, wait.
have to wipe it.
Cat years.
Wipe.
Oh, so we're back.
So this,
So
the grass portion goes down, and you see this arrow.
nitrate, calcium nitrate.
That's a line
That's what I
there.
figured, yes.
Yeah.
And then
So
very
line
little to
here. Okay, for the people that are online, this was as a hands-on kind of thing. So what we did is to
That's
measure
definitely.
electrical conductivity. You can see me in the samples and look up from the tables. Look up from the tables. How much nitrogen you get. For example, the table that I have up now on the left tells you for calcium nitrate what's the increase in EC corresponding to different level of nitrogen concentration. We use this method because it's quick. It's quick. The problem is that you need to have a table of somebody that has done the job before you to find the correspondence between EC and nitrogen concentration for that particular fertilizer, of course. And that on the left, I put a page from the book that gives you the electrical conductivity for various common fertilizers, and we're using calcium nitrate, that is a very common one. On the right-hand side, I put a similar table for that particular 17517 that is made by the manufacturer. So you cannot get any table. You need to get the table for that particular fertilizer. But then it's very quick, right? You can use an instrument like this that costs $100, and it has a battery inside, and it's very easy to measure the water before, because it will have some EC. Say it has 0.9, you measure it after, so it says it has 2.9, so now the increase is 2 decisiemens per meter. Then you go on the table and you look up for that increase how much nitrogen concentration it corresponds to. Okay, so this was the method number one. We're not measuring directly what you want to. So I wanted to make clear that we're not measuring nitrogen or nitrate or ammonium directly. We are measuring electrical conductivity, and somebody gave us a table to tell us the correspondence to nitrogen. So it's the kind of quickest and dirty. The second method, I'm gonna put
Okay. So we get a new one?
Yeah, you got to take that on. The second method is also kind of quick and dirty. We're measuring directly nitrate, but these instruments are not the most accurate in the world. What we used are colorimetric strip tests.
So what was in here before?
We gotta put these.
Hey, Jerry, we have a problem.
Of this one, I'll be there in a minute. Of this one, that basically you put this in the water and it develops a color, and you can read in this scale what's the color. It's very simple. The only difficult thing with this method is keeping track of the units. Keeping track of the units, like I said earlier, with the chicken and with the meat. The third method is a photometer. That is a machine. The third and the fourth methods are two photometers and I hope you can see them, people are still playing with them, is a machine that looks with an electronic eye at this sample of water that you put it in a little bottle that they call cuvette. So you put your sample in the cuvette, and the instrument shines some light through this sample and looks at it and measures the light that comes from the other side. And through this method, it measures the color. It measures the color of this water. And the way you use it, first you put your unreacted sample in the cuvette. It measures the color that it has. Then you add the reagent that makes the sample develop a color that is proportional to how much nitrate is in it or how much ammonium is in it. We have two of them, one for nitrate and one for ammonium. And then you put the cuvette inside the instrument again and you measure it again. So now the instrument, by the difference between the color before and the color after, gives you a proportionality and gives you a measure of how much nitrate or how much ammonium was in there. And then again, we have all the problem of the units, like we said with the chicken story, to convert into nitrate nitrogen or into ammonium nitrogen. And then when we have converted into ammonium nitrogen and nitrate nitrogen, then we can sum them up. We can sum them up to calculate total nitrogen. I hope I answered your question. Did I not? I'm gonna go and talk to these guys and come back to you in a minute. Yes, sir.
Okay, we're having problems with this. Where's MGC?
Yeah. And read the direction.
Me too.
Hey, I tell you though, you're reaching out.
Me too. Where's the one?
Yeah.
This is the one. This is the one.
You got a little bit of everything with me.
Thank you. We appreciate it. So this is the slide that I was talking about. You see, converting to unit of NO3N and NH4N. That's when you can sum them. That's when you can sum them. And again, to convert into NO3N, you divide by 4.43, and to get the ammonium into ammonium N, you divide by 129. So they both will get smaller, right? So they both will have to be divided by those factors, so they become smaller. Now you're only measuring the weight of nitrogen that is within that molecule, and now we can sum them, and we have the total nitrogen. Did I answer the question? What was the question again?
This measures what is available to the plants.
Yes. Nitrate, both nitrate and ammonium are very available to the plants. Other forms of nitrogen, including organic nitrogen, are not available to the plant as they are. There is some evidence that plants can take up amino acids, so that's a little bit more complicated, but most of the organic nitrogen is not available. So proteins are not available. Urea is not available as it is. So you need a process called mineralization that happens naturally in the soil. Thank you. See you later, guys. Sorry. I'm talking to the guys at home. Thank you for coming. So you need a process called mineralization. That basically microbial activity. These microbes digest, like eat up, degrade all these organic nitrogen, and they degrade it into ammonium. And then there are some other group of nitrification bacteria that, like I showed at the beginning, they're called Nitrosomonas and Nitrobacter, that turn it into nitrate. And so that's why when you buy organic fertilizer, for example, you buy feather meal, and the person you buy it from, they tell you, 70% of that is available, or maybe you buy guano and they tell you, 65% of that is available. They mean that within a couple of weeks,
all that protein will be degraded and will be available to your plant. 70% of all that nitrogen that is in it will be available to your plant to microbial activity. There is other organic fertilizer like manure that have lower quantity of nitrogen, but also less availability. So when you decide what organic fertilizer you use, not only you want to worry about the nitrogen content, but also about the percentage of availability. Did I answer your question?
Do you have recommendations for products that are well suited for organic certified farms?
You know, it depends a little bit on what you're growing, whether it's vegetables or trees or citrus or avocado. There are a lot of products that come from the slaughterhouses, and sometimes they're pelletized too. So there is when I was working in the Salinas Valley, a lot of vegetable organic growers use pelletized chicken manure. They refer to it as 442 because it has an NPK formula of 442. It's kind of ubiquitous. It's very used. Is one of the cheapest form of nitrogen that you can, organic nitrogen that you can buy. So 442 or pelletized chicken manure is one of them. There is feather meal that is also very used and is a byproduct of the poultry industry, and basically is the feathers that come from the slaughterhouses of chicken. There is blood meal that also is a byproduct of slaughterhouse of beef and stuff. And there is guano, another one that has a lot of available nitrogen. I think it's 12% is guano. These are all solid, like dry, like pelletized. Then there is another category of organic fertilizer that are liquid, and they're used because you can inject them in the irrigation system. You have to be careful because they plug easily your drip or irrigation system, so you need a filter. One very common of these liquid organic fertilizers is what people call fish emulsion. One of the very common one is called AgroThrive. I'm sure if you Google, you'll find it. I think it has 332 or 2.5, 2.52, something similar. Another one is called True Organic. Is a famous brand of this. They also make liquid fertilizer that comes from fish emulsion. Basically, comes from the byproduct of fish of industries of fisheries. I'm not an organic guy. My colleague Joji Muramoto is up in Santa Cruz. He's the specialist. He's the statewide specialist for organic agriculture. So he would be a good person to, better than me, to answer these questions. But more or less, these are the most common that you will find out there. And the last thing I want to say is that whatever you buy, be careful that you compare the things on the basis of how much nitrogen is in it. So if you buy something that costs $10 a pound that has 3% of nitrogen compared to something else that maybe is twice more expensive, but it has 4 times the nitrogen, maybe it has 12% of nitrogen in it, then the more expensive it's cheaper because there is more nitrogen in it. So if you're confused about these numbers, talk to me, send me an email or give me a call, and we'll sit together and we'll go through the math together. So I hope I answered your question. Okay, I'm gonna go hang out with those other guys and see what I get. Let's wrap up.
It's getting tighter. You guys are good? Yeah. Did you learn something?
Thank you everyone for joining us online. Please feel free to exit the meeting and we'll be sure to send you certificates of completion for your 1 hour of education credit.
Okay.
Thank you so much, everybody.